Hello, this video is about AI-powered Kubernetes debugging, or it should be AI-powered automated Kubernetes debugging. Wow, there are so many buzzwords and keywords in that title. Let's go and try to demystify some of them. When we talk about Kubernetes debugging, it can be quite tricky. In this channel earlier, I had shown how to use K8sGPT or a ChatGPT-like feature which enables us to debug Kubernetes cluster, and in subsequent video, I also showed how to use K8sGPT with its integration with Prerequisites to scan for vulnerabilities. All these things I was doing locally on my laptop. Now, it would be easier if someone else could do it for me, and automatically this can be part of my Kubernetes cluster itself. That is where today's video is all about. We are going to talk about using a Kubernetes operator and AI-powered engine, which is K8sGPT, to run things inside the Kubernetes cluster itself, so that continuously we will know if there are any issues with our Kubernetes cluster. And with the integrations that K8sGPT supports like Prerequisites, we will also get to know if there are any additional vulnerabilities or things like that. Let's get started and see how we can get this automated scanning done as part of the Kubernetes cluster itself. There are some prerequisites for this video. First and obvious one is that we should have a Kubernetes cluster with us, because we are going to run this inside a Kubernetes cluster. Next, we need Helm for deploying the charts which are required. Things like Prometheus and the K8sGPT operator is going to be installed using Helm. I'm going to use Helm 3, which is a package manager for Kubernetes. Now, you might ask, why do we need Prometheus? Just now I mentioned Prometheus. The reason for that is this particular K8sGPT operator, it uses something called as a service monitor. And this service monitor is part of the Prometheus Helm chart, or it is deployed as a custom resource definition, a CRD inside Kubernetes cluster when we deploy Prometheus. That is why we have Prometheus as one of the prerequisites for this particular setup to work. Let's get started and see how do we configure this. If we head over to the K8sGPT and the documentation, this particular section talks about how to set up in-cluster K8sGPT operator. But this one uses the default values. And if we deploy the chart using this, we will not have the dashboard, which is shown when we want to see the results into dashboarding tool like Grafana. So we need to override some of those things, and that is what I'm going to show in this particular video. So let's get started and first head over to the terminal. As I said, I'm going to have a Kubernetes cluster, and in the interest of time, since it takes some time to create the Kubernetes cluster, I've already gone ahead, created a Azure Kubernetes Service managed Kubernetes cluster and deployed my TechTalks application, which consists of a producer and consumer. And this has got several workloads running, like there are pods running, there are services running as part of this particular whole application which runs on the Kubernetes cluster. Next, we are going to go and install the Helm chart for Prometheus, which is a prerequisite for us. Now for this, I've created a markdown file, and I will be referring to that markdown file. All these setup instructions are part of this markdown. So if you want to create this same setup after the demo, you can refer to this markdown file, which will be available in the description. I'm going to paste this command here, and this is going to install the Prometheus. We are using Helm upgrade with the install flag. Prometheus is the name of the release we are going to use, and it is going to use this Prometheus stack. On this channel again, I have done in the past a video which talks about Prometheus stack and how it uses some default dashboards. There is one setting which we have to override in the default settings. This is to say that within the Prometheus specification, we want to disable this service monitor selector, and the setting for that is service monitor selector nil uses Helm values, and we set it to false. If we don't set this to false, then we are not able to get the matrix from the K8s operator that we are going to install next, and we will not have the data flow from the K8s GPT related objects to the Prometheus or to the dashboard. We won't be able to see that in the dashboard. That is why we have to send this particular value. And when we run this command, since I don't have the Prometheus release existing in my Kubernetes cluster, it is going to install Prometheus, and this might take some time to get installed. Once we have this installation done, we will validate that Prometheus is installed correctly, and we are able to access the Prometheus UI, and we are able to also access the Grafana UI or Grafana dashboards, which are linked to the Prometheus data source. While this is getting installed, let's head over to Lens and see what is happening. Lens is my preferred visualizer for the workloads which are running on Kubernetes cluster. In most of my earlier videos, you would have seen me using Lens. And here we would be able to see what are the different things which are currently deployed on my cluster. And we can see the status changing for some of the pods. There are deployments which are running, and same way we have other objects in this particular cluster. Now, if I scroll down here in the releases, we can see that there is this Prometheus release. It has been deployed. So looks like Prometheus is successful, and on the terminal also we can see that the Prometheus release has been completed successfully. With Prometheus installed, let's head over to Lens and see how we can access the Prometheus related settings or the services. Under the services here, we've got two main services for Prometheus. One is which is exposed on 9090. It is this one, the Prometheus Prometheus, and under the ports we see 9090 TCP port exposed here. And when we head over to the status, we can find the targets and service discovery. Under the targets, we see that Prometheus is currently scraping for all this Prometheus Grafana, then Prometheus Alert Manager, API server. These are the targets which are currently scraped. And same way, in terms of the service discovery, these are the different services which Prometheus is able to currently scrape. With that, we have the Prometheus setup and the matrices are being pulled. The other thing we want to see here before going forward is head over to the Prometheus Grafana service and access the Grafana UI. The email or the username is admin, which is the default one, and password would be prom-operator here. Under the dashboards, we should be able to see the default dashboard which are created as part of the Prometheus stack. With Prometheus installed, the next step is installation of the K8sGPT Operator. Let's head over to the terminal and install this using Helm chart. We are going to add a Helm repo from K8sGPT to our existing repos. We have the K8sGPT added to our existing repositories. Next thing for us is to update the repositories locally and get any changes from the Helm repos. And then we are going to run this Helm update command or Helm install command, and we will be overriding the settings. Some of these are required so that we have the service monitor enabled so that Prometheus can scrape the metrics. And secondly, we also enable the Grafana dashboard, and we will have a default dashboard created for us which will show us the details related to K8sGPT. I don't have the K8sGPT release running on my Kubernetes cluster, so it's going to install it now, and we should be able to see this installed pretty quickly. And in the results we see here K8sGPT has been deployed successfully. Let's head over back to Lens and see what are the objects which have been created as part of K8sGPT. When we go to the pods, we see this K8sGPT operator which has been created, or operator controller manager pod is created to run this as an operator. And then under the list of the custom resources, if we head down at the bottom of lens, we see this core.k8sGPT.ai, and there is this results custom resource definition object which is created. So the results of the scan or results of K8sGPT running continuously on our Kubernetes cluster will be stored as these custom resource object as results. With this, what is the next step? We have configured the operator to run. How does the configured operator knows from where it has to pull the results or which backend it has to use? For that, we need to create a configuration and create a Kubernetes object which is of type K8sGPT. And before we do that, we need to create a secret which will allow us to go and connect. So in our Azure portal, we have the list of properties associated with our OpenAI service that we created, and that has these keys and endpoints. These are the same settings we have used in the earlier video as well related to K8sGPT. We are going to need this endpoint and the key. We copy one of these key and we run these commands to create a secret, a Kubernetes secret. We need to export this key into the Azure OpenAI token. We can name this as any environment variable. I've already exported this, but we can do it again. So let's go and run export Azure underscore open AI underscore token is the name of environment variable. And this is the key that we assign, the one that we copied from the Azure portal. Next step is to create a Kubernetes secret using that key. So I'm going to run this kubectl create secret generic command, and the name of the secret will be K8sGPT Azure OpenAI secret. We use the from literal parameter, and the literal is Azure OpenAI API key. That's the key name we will be giving. And the value is the environment variable. And this we would put inside the K8sGPT operator system, which is the same namespace where we created this K8sGPT operator. So we specified the -n parameter here to create the K8sGPT operator system. And now we have the secret created. The next thing is to create this custom object of the type K8sGPT. If we look at the documentation, that is shown as inline object or inline YAML, but I prefer to do it by storing this as a YAML file. And if you look at the specification, we see that the kind of this object is K8sGPT. This is created, or this object is added as a custom resource when we run the K8sGPT operator. Then we specify the metadata in terms of the name and the namespace. And for the specification, regarding the AI, we specify these different parameters, like we want to enable the AI. The model is GPT 3.5 Turbo. Backend is Azure OpenAI. Base URL is the endpoint that we saw in the Azure portal. And then the engine. Engine is the name of the OpenAI deployment, which we created in the earlier video. So if we head over to the Azure OpenAI Studio, under the deployments, we will see the list of deployments that we have created. And this engine refers to the name of that particular deployment which we want to use. So here we have the name of the deployment in the list, and this is the same deployment name, what we specify as the engine. And then it requires that API key, which we use by means of that secret. We refer or we infer this particular secret from the Kubernetes secret that we created. With this, we are going to go and apply this particular manifest file. Let's go and apply this K8GPT config YAML file to our Kubernetes cluster. I do that by running k8 apply -r-f and dot. So we see here that the K8sGPT has been created. And now if we go back into our lens and we look at the K8sGPT, we see that this instance or this object has been created in the Kubernetes cluster. With that, we have configured the K8sGPT operator to use the configuration file or the configuration parameters that we require for connecting the K8sGPT to the Azure OpenAI backend. Now, let's go and look at the results. If we go back to the Prometheus and we refresh these service discovery and the targets, here we should be able to see things which are added for K8sGPT. So at the bottom here, we can see K8sGPT operator controller matrix has been added to the targets, and same way in the service discovery, we have the K8sGPT operator controller matrix coming in. With that, we know that the Prometheus is able to scrape the matrix now regarding the K8sGPT. Let's go and refresh the Grafana dashboards section. And here we see another dashboard added, K8sGPT overview. If we click on that, we will see the analysis results. There are 13 results analyzed, or there are 13 different things identified by the K8sGPT operator automatically running inside the Kubernetes cluster, and 10 of these are related to the services, and then 3 are remaining related to the pods. This gives us the summary of the results, or this gives us the summary of the issues identified by the K8sGPT operator. How do we see these results? We can again head over to the terminal and then use that results object, or kubectl get results. Then we specify the namespace as the K8sGPT operator, and we specify the output as JSON, and we use this JQ utility to show us the result. And in the output, we can see the results here. We can look at one of these. So the service related ones, which we were seeing majority of the issues reported were related to the service. The details are mentioned here, saying the service has no endpoint, it is expecting traffic on label. And then there is also a solution proposed here to check the labels of the service and ensures that they match the expected labels. This is regarding the kube system extension operator service namespace, and it also shows us what are the other labels that we have, or what are the things which are used during this particular scanning. So we can identify which backend was used, what is the name of the K8sGPT instance, and what's the namespace where this is running. And in terms of the other details, it will also show us this is regarding the extension operator matrix service. That is the service which is having this problem, and what is the issue that is reported as part of the scan. Now let's go back and try to change something in terms of our deployment. The producer deployment that I have, I know based on my previous experience that one of these tags, which is the TikTok's producer Java, has a problem, and I'm going to run the Go version of this. So we will do the same thing, kubectl apply -r-f, and then apply all the files in this directory. And we see that the producer deployment has been configured, which means that now it will be using the tag for Go, or the programming language as Go for TikTok's producer, and we didn't change anything in the producer service. Now with this, over a period of time, we can change the frequency here. Instead of running it for last 3 hours, let's say last 15 minutes, and we do this to refresh the dashboard automatically for after 30 seconds. We have 13 analysis results. When the next scan is done, we can find some change here in terms of the analysis. So let's give it few seconds for the analysis results to come through and see if we see any change as a result of changing that deployment. We can also go on to the lens and see if anything has changed in the lens side of things. So everything seems to be running fine, no issues. And if we go into the pods and we look at RabbitMQ producer deployment about 67 seconds ago or 70 seconds ago, these 3 replicas have been refreshed. So let's refresh the dashboard again, and we see that now the number of issues have come down to 8 from 13 because the earlier deployment had some issues. And in this summary or in this dashboard, we can see the count of issues falling down from 13 to 8. And these are all related to the service. These are no longer related to the pods. So this way, this particular dashboard can give us a historical view of how things have changed over a period of time. If there are deployments happening, or if there are new vulnerabilities or new issues found, we can identify those, or we can visualize those, how the issues have transitioned or how the issues have progressed over a period of time. And with that, we have come to the end of this video. I hope that you found this useful. What we saw during this was how to configure the K8sGPT operator to run inside the Kubernetes cluster as an in-cluster operator and to run it continuously. We require a couple of prerequisites for this. One being the Prometheus, which is required for having that service monitor object or custom resource definition available within our cluster, which is used by the K8sGPT operator to monitor the services. Then we used Helm to deploy the K8sGPT operator in our Kubernetes cluster. And we also configured that to use the Azure OpenAI as the backend by specifying the configuration in a YAML file. I hope that this is useful for people who work on day-to-day basis with Kubernetes, people like site reliability engineers or DevOps engineers, and even developers who need to know what is happening inside that cluster and what are the issues which can come up because of the changes to the workloads. Getting this automatically scanned is a very good way, and it gives the operators a handy way to identify how the cluster is behaving, how the different workloads are operating under different conditions. I hope you found this useful. If you like this video, please hit the like button, subscribe to my channel for future videos, and hit that bell button to get the notification when new videos are published on the channel. Thanks for watching this. Until next time, code with passion and strive for excellence.